Thomas True. I'm a Senior Applied Engineer for Professional Video at NVIDIA.
And I'm Mike Bergeron at Panasonic, and Tom, thank you for coming out and speaking with us.
Glad to do it.
All right, now you were involved with KAIROS development way back before we had a name for it, going back early on. And I know from the beginning we always try to avoid calling a KAIROS a server. It's a mainframe or it's a core. What makes it not a server?
Well, it's a software-based switcher that incorporates an NVIDIA GPU and NVIDIA Connect networking interface that allows for video processing and high network connectivity to support SMPTE 2110 switching of SMPTE 2110 workflows.
Okay, and I understand that we're running an enterprise class hardware for the server, and we're using Linux, but not all the Linux, right? That's
correct. With the NVIDIA GPU and network interface ConnectX, we have kernel bypass, so you can bypass and communicate from the KAIROS switching application directly to the GPU and directly to the network interface without going through the traditional OS networking stack.
Right, and is that going to bog it down?
Yeah, so by using kernel bypass, you get rid of all the non-determinism that's introduced by the traditional OS network stack.
Oh, that's great. So that's going to be more reliable, right?
Correct. And then another feature is that both the network interface and the GPU can do GPU direct. So the video essence can go directly to and from the network interface and the GPU without going through the system memory of the system. So the two devices can DMA the memory, the video essence directly between them.
We're almost using the GPU like a big FPGA.
That's correct. The GPU is used for all the video processing and color processing, things like that.
Right. It kind of wakes up by itself.
Yes.
You don't need. It doesn't need his mother. Okay.
Yeah, that's right.
So besides being more reliable, and you mentioned reducing the determinism, that seems to have a lot to do with how we're getting a very low amount of delay. I mean, when everything's going well, you're getting a frame delay in to out. I mean, that's generally not possible if you're running video out of a computer.
That's correct. Using the combination of the kernel bypass and the GPU direct technology between the ConnectX-6 network interface and the GPU, you can get high determinism of timing, and the result is the lowest latency possible.
Now that was really a goal, like to get the GPU into the market of video processing. That was what you guys were trying to deliver, so you could get that kind of performance.
Correct, because the GPU is a highly parallel floating point processor with thousands of cores. The GPU is ideal for processing video because it can work on all the pixels of a video frame in parallel and do it in nanoseconds with the least amount of latency possible.
Right. So I think prior to that, there was a lot of video being used, a lot of video being produced on servers and PCs and things like that. But for a live on-air broadcast, you weren't seeing too much of it.
Correct. KAIROS was kind of like the leader. It was like the first software-defined switcher that really incorporated the NIC and the GPU and had them working together and to deliver a professional switching product into the broadcast market.
Right, and we were talking before about how a lot of our test engineers were testing capabilities of the GPU ahead of some of the QA guys, like that when the schedules were, they would say, hey, by the way, this is working.
Oh, that's correct. Yeah. Like we would say, oh yeah, the NIC can do this and the GPU can do this, so in theory you should be able to do this. And yeah, the KAIROS development team would come to us and say, yeah, we already tried that and it works and it's great.
Now, we're not only getting the GPU with NVIDIA, the NIC card, the 100 gig NIC card, which was also very new to the market at that point, that's all part of NVIDIA now too.
Correct.
Now, when we're able to join that NIC card to the GPU, how is that that's going to really facilitate us being able to deploy 2110 network?
Correct. Again, because of the lowest latency that's possible, because of the GPU direct technology between the Connect X6 NIC and the GPU, we can do subframe transfers and give high determinism of the timing to meet the strict timing requirements of the SMPTE 2110-21 specification.
Mm-hmm. Mm-hmm. Yeah, no, and we're getting to the second generation, and of course we're moving to more hardware, and I think in the future we're going to try to add more functions onto that. I mean, what are you guys where are you seeing things heading with this technology?
Yeah, so we just see more better. I mean, we're coming out with new GPUs with higher core count, so you should be able to do more GPU processing within the time of a frame, like a frame time. And then the NIC, the ConnectX NIC technology is advancing with going from 100 gigabit now to 200 and 400, and we have the hardware engines on board to do the packet processing required for SMPTE 2110, and to reduce the latency, and it's just more better coming down the pipe.
Excellent. Yeah, I know the development team is experimenting with some of the newer hardware. You know, the future thinking on that. And I think where we've gotten with the current generation is that we're able to really meet a like a sports arena spec,
right,
and get something at that scale.
We also have what we call DPU technology, data processing unit, which incorporates ARM cores onto the network interface card, so that you can run within a container, a Docker container, processing applications. And one application that we do is through a Docker container, we can move the whole PTP stack for precision time protocol onto the network interface card now, so that the operating system doesn't have to manage that either. So that adds even more determinism into the pipeline.
Now, that all has to be very necessary for us to be able to deploy a 2110 going right into the GPU, right?
That's correct.
Okay.
Yeah, I mean the engines on the network interface to do the kernel bypass, as well as the packet pacing, give us that high determinism, low latency from the network card into the GPU to give us the low latency that is required for KAIROS.
Right. And that was, I mean, and that's got to be a very tight spec to meet the SMPTE requirement.
Correct. That helps us meet the 2110-21 specification.
Oh, that's great. Well, thanks for joining us, and I appreciate the work that we've done with NVIDIA, like really over the last several years, and we're really very much looking forward to the next generation hardware and see where that brings you and where that brings us. So, Tom, thanks for joining us.
Thanks.